Hi guys, we're on Unit 5, Day 7, and we are going to learn our last of our 5 triangle congruence theorems. Okay, and in our warm-up it says find the unknown angles and explain your calculations. So we got a couple of clues here. We have a 112 and a 54. We also have a clue that our lines are parallel. They're indicated by those little arrows on them. So we could think about parallel lines maybe being cut by a transversal and help us. But I'm going to do something real quick because I know that in one intersection, if I know one of the angles out of the 4, I know all of the others. And so I'm going to go ahead and use vertical angles and get a 112 here. I'm going to use vertical angles up here and get a 54. Okay. And then I'm going to use something called a linear pair, where I know that these two angles lie on the same line with a separator in between them, that they make up that half circle, which is 180 degrees. So 180 minus 112 will give me how many degrees on the other side of the separator, which is 68. And then I know his vertical angle would also be 68. Okay, I'm going to do the same thing with the 54s, because they are on a line with a separator in between, and those two angles there would add up to 180. So 180 minus 54 is 126. And so this angle is 126, and so is his vertical angle pair. All right. So now, guys, I'm going to go ahead and highlight my pair of parallel lines, which are these ones. And I'm going to highlight one of my transversals. Okay, and I'm going to highlight this transversal on the top that cuts through those two parallel lines. So now I know exactly where to slide my angles. Okay, if I take this intersection here and I slide it down the transversal, it's going to be the same intersection down there. And so I now can go ahead and fill in this is 54, that E is 54, and there's one of my answers. Okay, I can also mark this as 126, and this is 126 if I wanted to. Okay, I'm going to go ahead and highlight my other pair of parallel lines. So these are also parallel, but I'm going to use this bottom line as my transversal that cuts through it. And I'm going to go ahead and take that one intersection that I already have filled in and slide it up the transversal and copy it into that intersection. And so F, guys, as soon as I do that, is 68, and that's one of my other answers. Okay. I can also put this as 112, and this is 112, and I have now filled in every single angle in that picture. Okay. All right, hopefully that helps. All right, guys, so going down, it says any combination of 3 congruent pieces does not always ensure congruent triangles. In fact, we saw that the other day in the warm-up with angle, angle, angle. We know that that doesn't mean that the triangles have to be the same size. It just means that they have to be the same shape, and so that doesn't mean that they're congruent. Okay. This is another one that doesn't work, which we've talked about. We call this the donkey theorem because it spells another word for a donkey. And angle side side doesn't ensure congruent triangles. If you can take a look at this picture here. All right. I want you to look at this triangle here. That triangle right there has a side of 9, a side of 11, and an angle of 23. And they took that triangle and they redrew it over here. Okay. Taking a look at one of the other triangles in the picture, the whole picture, hopefully you can see that triangle. And in this triangle, guys, this red one also has a side of 9, a side of 11, and an angle of 23. And I think that you guys can see, even though they have 3 pairs of congruent parts, okay, spelling out the theorem, angle side, side, because the angle's not between the sides, that these two triangles, the red and the gray one, are not even close to being identical twins. Okay, and so hopefully you can see why this theorem of angle side, side does not ensure the triangles are identical twins of each other. Okay. All right, so going on, there is actually a special case of ASS that works. Okay, it depends on what kind of A you have and what kind of S's you have. If that A is a 90-degree angle, it will work. All right. If your S, which is one of the sides of a right triangle, okay, is a hypotenuse, and the other S is a leg, it works. All right. However, guys, because the A has to be a specific angle, the S has to be a specific side, and the other S has to be a specific side. They do not call this theorem ASS because then other people think that it'll work on any angle and sides. All right, so they name this theorem HL. However, I like to name the theorem, and so do many other math teachers, RHL, okay? Because it makes you realize that the A that you have for an angle has to be a right angle, and so they put an R there, okay? So this theorem works is in if two right triangles, okay, the S has to be the hypotenuse of it, so we're going to say the hypotenuse, which remember is the longest side, also the side across from the right angle. Okay. And the other S is the leg, which is one of the other sides of the right triangle. If you have a right angle, a hypotenuse, and a leg, and they're marked being congruent in one triangle, and you have the same three pieces, okay, marked in another triangle, then the two triangles are congruent. Okay, so we can take a look at what a picture might look like. But if we have a right triangle and we have another right triangle, meaning that they have right angles, that across from the right angle, that side called the hypotenuse is marked, and one of your legs is marked, okay, then this would be an RHL, and these two triangles would be congruent. Okay. Also notice, guys, they could have the other leg marked. So if I take the tick marks off of that leg, but I mark this leg instead, I would have to mark that same leg there. Okay. But it does not matter which leg you mark as long as it's the same leg in both triangles. Okay. We're going to go ahead and skip this next part here. And we're going to go to the back side of our notes. And so I will see you guys there in the next video.